Suppose a simple random sample of size n equals, lowercase n, equals 1,000 is obtained from a population whose size is capital N equals 2 million and whose population proportion with a specified characteristic is p equals 0.65. Describe the sampling distribution of p hat. So again, we want to check our conditions. Our first condition we want to check is that our sample size is less than or equal to 5% of our population size. So let's look at 5% of our population there. So 5% of 2 million. So 0.05 parenthesis 2 0 0 0 0 0 0 close parenthesis enter. So that is 1 0 0 0 0 0. So 1,000 is less than or equal to 100,000. So that condition's met. So now we want to check to make sure that n times p times 1 minus p is is greater than or equal to 10. So 1,000 times 0.65 times 1 minus 0.65. So let's type that in our calculator. So 1,000 parenthesis 0.65 close parenthesis open parenthesis 1 minus 0.65 close parenthesis enter. So we get 227.5, which is greater than or equal to 10. So that condition is also met. So both of those conditions are checked, so we know that we're dealing with a approximately normal distribution. So now let's find our mean of the sampling distribution of p hat and the standard deviation of the sampling distribution of p hat. So the mean of the sampling distribution of p hat is just equal to p, which is 0.65, and the standard deviation of the sampling distribution of p hat is equal to the square root of p times 1 minus p over n. So let's calculate that. So plug everything in. So let's simplify a piece at a time. So 0.65 times 1 minus 0.65. So we get 0.2275 over 1,000. Oops, fix that up there above and underneath our radical. So let's go and divide that by 1,000. So again, we have scientific notation. So we're going to leave it in this form to use a normal CDO. But that's approximately equal to, so let's do second x squared to give us the square root symbol, and then second negative, we'll insert the previous answer in there and then press enter. So this is approximately 0.015083. So we have that our sampling distribution of p hat is approximately normal with mean of 0.65 and standard deviation of 0.015083. So let's continue on and do some problems. So we want to know what's the probability of obtaining X equals 690 or more individuals with a characteristic. So you always want to make sure you're converting these to say the probability that P hat is something. So notice we have the probability that X is greater than or equal to 690. So we need to convert that into a probability that P hat statement. So to do that, we're just going to say the probability that P hat is greater than or equal to 690 over, and then we're going to pull our sample size there. So 690 over 1,000. And everything's going to be done the exact same way. So we're going to do normal CDF. And then our lower bound would be the 690 over 1,000, and that would give us the percentage of the population with that characteristic. The reason I chose to leave it as a fraction, that'll give us a more accurate result. Right? And then 1E99, and then our mean, which is 0.65, and our standard deviation, which is the square root of 0.2275 over 1,000. So let's type that in and see what we get here. So second bars to 690 over 1,000, comma 1E99. So again, to get the E, you're going to do second comma. All right, comma after the 1E99, 0.65, comma, second X squared will give us the square root, 0.2275 divided by 1,000. Close our parenthesis to end the square root, close it to end normal CDF, and then enter. So 0.0040. So there's our probability of obtaining 690 or more individuals with the characteristic. So the next one, we want to know the probability of obtaining 620 or fewer individuals. So they're working out the same way. So the probability that P hat is less than or equal to 620 over 1,000. So normal CDF. And this one's going to be negative 1E99. Right, because we want the area to the left of that value since we're talking about less than. So comma 620 over 1,000. And then our mean, which is 0.65, and then our standard deviation, which is the square root of 0.2275 over 1,000. Let's see what we get here. So second bars to negative 1E99, comma 620 divided by 1,000, comma 0.65, comma square root 0.2275 divided by 1,000. Close parenthesis, enter. So 0.0234 there. There's our answer.